and welcome to day 4 of Advent of Code 2018 in Python. My name is Sarah Moreno, and this channel is called Domain Expert. Last time we did Challenge 3, and I only managed to do the first half within an hour. I was kind of tired, so ended up cutting it off there. I think I was tired in general on that one. This time around, we're going to be doing Challenge 4, and it's more of the afternoon here in New York. And hopefully I have some more energy and I'm able to do both. So let's see how it goes. I've put some thought into making the terminal more readable for folks that might want to view this on a mobile device. So please give me feedback as to whether or not this font is large enough. If you don't like the colors, I ended up going with this color for Advent of Code. I think the red and green is a good, nice touch. It's very Christmassy. I hope you like it. What else did I want to mention before we dive into it? Yeah, like if the font isn't big enough, just let me know, and I'll make the font bigger. So day 4. Excuse me. Repose record. You've sneaked into another supply closet this time. This time, it's across from the prototype suit manufacturing lab. You need to sneak inside and fix the issues with the suit, but there's a guard stationed outside the lab, so this is as close as you can safely get. As you search the closet for anything that might help, you discover that you're not the first person to want to sneak in. Covering the walls, someone has spent an hour starting every midnight for the past few months secretly observing this guard post. They've been writing down the ID of the one guard on duty that night. The elves seem to have decided that one guard was enough for the overnight shift, as well as when they fall asleep or wake up while at their post, your puzzle input. For example, consider the following records, which have already been organized into chronological order. Guard 10 begins shift, falls asleep, wakes up, falls asleep, wakes up. Guard 99 begins shift, falls asleep, wakes up. So I guess they wake up and let the other guard begin their shift. Falls asleep, wakes up, begin, asleep, up, begin, asleep, up, begin, asleep, up. Timestamps are written using year, month, day, hour, minute format. The guard falling asleep or waking up is always the one whose shift most recently started, because all asleep-awake times are during the midnight hour, 0 to 59. Only the minute portion, 0 through 59, is relevant for those events. Visually, these records show that the guards are asleep at these times. Okay, so 10, 10, 1, 2, okay. So 10, I'm actually having trouble reading and understanding this. The columns are date, which shows the month-day portion of the relevant day, ID, which shows the guard on duty that day, and minute, which shows the minutes during which the guard was asleep within the midnight hour. The minute column's header shows the minutes tens digit in the first row and the ones digit in the second row. Awake is shown as dot. So awake is dot, and asleep is hash. Okay, so this paragraph helps you understand this diagram. Note that note that guards count as asleep on the minute they fall asleep, and they count as awake on the minute they wake up. For example, because guard number 10 wakes up at 25, I guess that would be the 25th. 10, 10, 5, yeah, 25th. Note that guards count as asleep. For example, because guard number 10 wakes up at 25 on 15/18/11/1, minute 25 is marked as awake. So I think it's this, or this. Minute 25 is marked as awake. If you figure out the guard most likely to be asleep at a specific time, you might be able to trick that guard into working tonight, so you can have the best chance of sneaking in. You have two strategies for choosing the best guard minute combination. Strategy 1. Find the guard that has the most minutes asleep. What minute does that guard spend asleep the most? In the example above, guard number 10 spent the most minutes asleep, a total of 50 minutes, 20, 25, and guard 10 has two entries. Maybe these are 2 days. So 20, 25, and 5. Oh no, sleep. 20, 25, and 5. They were asleep, while guard 99 only slept for a total of 30. So 1, 2, 3, 30. Guard number 10 was asleep most during minute 24 on 2 days. So this day. Whereas any other minute the guard was only seen on 1 day. Whereas any other minute the guard was asleep was only seen on 1 day. So that's a grammar typo. Whereas any other minute the guard was only seen on 1 day. Whereas any other minute the guard was asleep. The guard asleep was only seen on 1 day. While this example listed the entries in chronological order, your entries are in the order you found them. You'll need to organize them before they can be analyzed. What is the ID of the guard you chose multiplied by the minute you chose? In the above example, the answer would be 10 times 24 equals 240. What is the ID of the guard you chose multiplied by the minute you chose? A guard and a minute. And so what's the criteria for choosing a guard and a minute? Okay, so let's look at the input. Okay, I'm gonna make their 04 day 4 CD get. That's a bad request. It's very odd. Why can't I copy that? Puzzle inputs differ by user. Please log in to get your puzzle input. I did not know that. Interesting. So I can't just directly get it from the terminal. Anyway, just do it this way. Or pb copy input.txt. That's not it. Good? Okay. Okay, so excuse me. So we have this input, and then we're going to want to make a solution dot pi. Whoops. Solution dot pi. Python solution dot pi is nothing. And I like to have the Python REPL open, just for my own benefit, because I don't know the language in like by heart, to be perfectly honest, and that's okay. Yeah, I might have to reread this. You've sneaked into another supply closet. This time it's across from the prototype suit manufacturing lab. You need to sneak inside and fix the issues with the suit. But there's a guard station outside the lab, so this is as close as you can safely get. As you search the closet for anything that might help, you discover that you're not the first person to sneak in. Covering the walls, someone has spent an hour starting every midnight, covering the walls every midnight for the past few months, secretly observing this guard post. They've been writing down the ID of one guard on duty that night. So there's only ever one guard on duty per night, right? Because, yeah, these are different days. The elves seem to have decided that one guard is enough for the overnight shift, as well as when they fall asleep or wake up while at their post or post input. For example, consider the following records, which have already been organized into chronological order. So apparently there's a stalker that's been observing the guard on duty every night. Timestamps are written using year, month, day. The guard falling asleep or waking up is always the one whose shift most recently started. Sure. Because all asleep-awake times are during the midnight hour. Interesting. Okay, so this all represents 1 hour at midnight. Only the minute portion is relevant for those events. Okay, so there is an hour here, but it's never not 0. Or, I mean, that doesn't seem to be true. We have 23:59, but I think that's the edge case. Well, they have 23:57 here. Um, yeah, 23. I don't know how to interpret that. It might be just be realistic. So 23:48, just like realistically, the guard which would start before before midnight into midnight, wakes up, wakes up. Well, these are different days. These are different days, so I probably want to sort them by day, right? For starters, because these are different days. Oops. Okay, but if we were to sort them, we might get something like this. Actually, that could be a good exercise. I wonder if there's a way to sort lines in them. And I think alphabetically would work. Select the lines visually and Shift V. Ah. And then invoke sort. Yeah, that worked. And presumably, there's only one guard. Right, so guard blah begins shift, falls asleep, wakes up. There are multiple guards. No, that's the 14th. On the 14th, guard blah began their shift. They woke up, fell asleep and woke up. And then their shift ended at 1 a.m. on the 15th. Guard blah started towards midnight of the 15th, fell asleep, woke up before 1. Presumably the shift ended at 1. Guard blah started the next midnight, fell asleep 13 minutes in, woke up 20 minutes before the end of the shift. This guard on the 18th, the night of the 18th, the night of the 17th rather, and into the 18th, fell asleep and woke up several times. Okay, so I think that makes sense now. Makes more sense. I'm just skimming the input. I saw some oddness here where guard blah begins a shift on the 20th. Their shift would end 1 a.m. on the 21st. And then the next guard would begin their shift on the 22nd. I guess there was no guard on duty on the 21st. That's odd. Okay. So thank you, robots. There's a Vim sort there, so. Timestamps are written using year, month, day, hour, minute. The guard falling asleep or waking up is always the one whose shift most recently started because all asleep awake times are during the midnight hour. Only the minute portion is relevant for those events. Visually, these records show that the guards are asleep at these times. So, fell asleep, fell asleep, fell asleep once, fell asleep once, fell asleep once, fell asleep once. The columns are date, which shows the month day portion of the relevant day ID, which shows the guard on duty that day, and minute, which shows the minutes during which the guard was asleep within the midnight hour. The minute column's header shows the minutes tens digit in the first row and the ones digit in the second row. Awake is shown as dot and asleep is shown as blah, as hash. Note that they count as asleep on the minute they fall asleep and they count as awake on the minute they wake up. Because guard number 10 wakes up at 25 on 15-18-1-11-1, minute 25 is marked as awake. If you can figure out the guard most likely to be asleep at a specific time, you might be able to trick that guard into working tonight so you can have the best chance of sneaking in. You have two strategies for choosing the best guard-minute combination. What's the second strategy? Find the guard that has the most minutes of sleep. What minute does that guard spend asleep the most? Okay, so that's one strategy. So find the sleepiest elf. Find the guard that has most minutes of sleep. And then for that elf, for sleepiest, what guard spend asleep the most? Find sleepiest minute. And that's one strategy. In the example above, guard number 10 spent the most minutes asleep, a total of 50 minutes. while guard 99 only spent 30 minutes asleep. And then for guard 10 was asleep most during minute 24 on 2 days, whereas, um, okay, so then you would want to find if there's any overlap among the sleepiest guards, the sleepiest, the sleepiest elves, the sleepiest elves, sleepiest moment. While while this example listed the entries in chronological order, your entries are in the order that you found them. You'll need to organize them before they can be analyzed. So I already did that. I already sorted them. That was easy. At least with them, it's easy. What is the ID of the guard you chose? And then so we found the sleepiest elf, and you multiply it by their sleepiest minute, and that's the answer. Okay, so not too bad, it seems. Not too bad. Once we understand the problem, yeah. Once we understand the problem, it's not too bad. It's okay. Just looking at the clock. Great. So maybe let's borrow from yesterday's solution. And yeah, so this is a new terminal theme, and I haven't actually used it for programming. I'm finding it difficult to read the comments for one, so I may change the theme for tomorrow. But basically, we have this input, and we read it. Open this day's input file, input.txt, blah, and sort of like lines is equal to input.read split, blah blah. Um, Print lines. That's the first 10 items. Okay, so that seems right. So we've read the input. Read the input, and then find the sleepiest elf. Find the sleepiest elf. So we need to, we need to sort of um, calculate the ranges. So here's a, and they always wake up, it seems like. We're only concerned about the falling asleep bit. So when they begin the shift, they're always awake, presumably. And they may fall asleep, they may not. Sometimes they don't fall asleep. Right here, these guards did not fall asleep. They're on their shift. These are good elves. Oh, 2083 is such a good elf. It's so I need to sort of parse maybe I don't want to delimit by new lines. I mean, new lines are decent. How about shifts? And I want to sort of group by group by lines, group by shift. If anyone understands SQL, so and then for line and lines, basically we're gonna shifts and then shift is equal to blah. As we parse through the lines, if line, and I know from previous experience that you can just check for membership in the string by using in, and if it has the string guard, if it has a string guard pound, then we have begun a shift. We're going to go ahead and shift append line. And then, actually a couple of things. So if we have already, if guard inline, if shift, so I'm wondering if an empty list is truthy. If a print foo. So an empty list is falsy in Python. So if the shift list has something, I want you to go ahead and we've seen a new shift. I want you to go ahead and append into shifts this current shift, and I want you to go ahead and clear this current shift. Hopefully that does what I want. So basically we're pushing anything that we've accumulated in the shift, in the current shift, into shifts as a full shift, and then we clear the currently running shift so that we can begin a new shift by appending the shift we've just detected. And that's it. And then now hopefully we would have all of the shifts here. So I would like to sort of, as a sanity check, check out maybe the last one. I think -1. Print out the last one. Guard 3373 begins the shift. And is that kosher? Is that fine? No, that's not. 23373. It seems to sort of stop here. It's -1. What happens if you... What's the first one? 2851. Begin shift. So yeah, I think there is some scoping issues here where I can't just dump in the shift like that. And so maybe this line-based process isn't good. How about for iron range length of lines? I just feel like this here should be going through it in order just fine. So it goes through it in order. Shifts is a list, and the current shift is a list, and if guard pound is equal to line. Oh, I'm not appending the. I'm also not appending just the regular lines. If blah, else it's just a sleep or waking up thing, and so I want to do a shift append line. Yeah, I don't think that's going to actually change much. So blah falls asleep. And it doesn't seem to pick up the switch over if guard pound inline. I mean, guard pound, they all of these have guard pound, guard space pound. Falls asleep, wakes up, falls asleep, wakes up, falls asleep. Begin shift. And there's no end shift either. What is this, 1,000 lines? Just enough lines that I can sort of skim it just fine. Falls asleep, falls asleep, falls asleep. Oh, this stuff isn't sorted. So I sorted it in the editor, but I didn't actually sort it in the input. So I'm gonna go ahead and try to sort it using a Unix pipeline. How about that? So that's the original, and then I want to sort of take that last one. I want you to go ahead and sort it, and I want you to go ahead and pipe it out to input.txt. And I think I can just cat it that way. Yeah, probably cat it. And then, yeah, that's funny. So that, ladies and gentlemen, is how you sort a file with no programming. Just Unix. That's sorted. Basically, this line here. Basically, we echo out the file, we pipe it into the sort tool, and then we write out the results to a file. For those that want to learn more about the sort tool, you can read the manual on sort by invoking mansort, and you can read to your heart's content on the built-in sort function in your computer. If you're on Linux, basically sort or merge records, lines of text, and binary files. Let's see. So, maybe not works. Maybe, what do we get? Okay, much better. We get the 2939 there. I do want to keep on consulting this. So 2939 begins the shift, falls asleep, wakes up, and blah. And then let's try to see the first thing I was trying to see, which was the last item. I would like to see the last item, which is 2137, begins the shift, falls asleep, wakes up, and this is not right. So 15, 18, 22, 15, 18, 22. Right. So 1122, then 1122. What is this? There's some funkiness here. 1122 at midnight. They began the shift. 29 they fall asleep. 35 they wake up. 53 they fall asleep. 55 they wake up. 11, 22, 23. The same guard began their shift. And then on the 23rd they fell asleep. And they woke up on the 23rd. What is this saying? 2137 begins the shift. 1122 0029 falls asleep. So it's like jumping from. No, it's reading that. It seems to be reading it in order. 112200 begins shift. 112229 falls asleep. Wakes up. Falls asleep. Wakes up. Oh, so that is correct for this. For the penultimate one, and I just wasn't able to capture the last one. So there's an off by one error. And that's a -1. I think -1 returns the last item. Yeah, so we're just not getting that last one. And that's because I'm doing an if on this, else shift out append, and then finally shift dot append one final time, append the current shift. And then it works. Then we get this last one, which is 3 entries. Begins to shift, falls asleep, and wakes up. Begins to shift, falls asleep, and wakes up. Okay, so I'm pretty happy with how I'm parsing that now. Not happy with that helper function called input. So we've grouped by, which is what I wanted. I've sort of grouped the entries by the shift. And so if I were to maybe look at the first 3 entries as another sanity check. Began the shift, and that looks right. I'm basically looking for some nested lists. And then, let's see, those are all the shifts, all the lines, all the log entries grouped by shift. And then I probably want to group the shifts by the guards. So I'm going to introduce some comments here. So group lines by shift. And then down here, we're going to group shifts by elf. And so how would you do that? So for shift in shifts, I'm gonna, for every shift in the shifts, let's start keeping track of the elves. For shift and shifts, the shifts first entry will have the guard, and then the elf ID is equal to, if we wanted to use a regular expression, I think we could re dot just want to grab the number in it. You can do search, compile, debug, ignore, locale, search, match. So that's a Boolean. No. So it looks like it would just do match. So A is equal to ABCD 45 ABCD, and then RE dot match the pattern, and the pattern I'm interested is in some sort of digit or several digits. A. What does that do? Maybe I should just use search. Results is equal to that. Result dot Eventually, I'll memorize this, but not today. Group 45. Okay, so I think we can do that. Re.search. Search for some sort of one or more digits in shift. So presumably we can be pretty sure that it's a reasonable assumption that the first entry in every shift will have the elf ID. So I'm not going to protect this very much. So we can get the elf ID that way. And then group elves shifts by elf. Right. So this could probably be a dictionary. And then elves. Let's assign into elf ID the shift, or basically if there's an entry, if we've seen this elf before, I want you to append into it, and we're going to be making a list. Append the current shift. Otherwise, we're going to initialize it to an array containing that shift. And then we can do sanity check on this. Print elves line 25. Oh, so dot group So that should be the ID. 1518. Oh, so that's not a good regular expression because there's some numbers in the beginning. Um, maybe. I mean, we could, just in the interest of time, we could just say that the match has to include the hash. And I think it'll respect that as a value if else elf ID. Oh, you can't you can't just do an if and expect it to be protected that way. You have to do, I think, if elf ID if elf ID in else dot value keys. So dict a 1 if a and d dot keys want you to print foo. Okay, so that is valid. That is a valid way to guard access into the dictionary. And what is this? So I'm looking for a dictionary entry. Okay, so 2297 has several shifts. One shift um, that's one shift. It begins their shift, and then they began their shift and did not fall asleep, so that was a good elf. And before that, 1171 also began two shifts. And I wonder if there's a pretty print. P print. Data pretty printer. And can I how do I use it? pp dot pprint blah, where pp is equal to blah. So you specify the indentation, and then pp dot pprint else. Much better. So so these are all entries for the first guard. 821. Just because I can, I'm gonna reduce the indentation of 2. Honestly, I'm more of a JavaScript person anyway. Sorry. Sorry, not sorry. Indentation of 2. So that's the shifts for ELF 821, and these are the shifts for ELF 3491, and 3433, 343373. Okay, good. So, okay. So this is I think this is a pretty SQL-ish sort of approach to solving it. Basically, we have some lines, and I group them by shifts, and then I group the shifts by elves. But now, finally, we can sort of determine the sleepiest elf. I think pretty easily. The sleepiest elf. Find sleepiest elf. We could, for every elf in elves, print elf, and this is just a sanity check because I don't know if I can actually even do that with a dictionary. I can. For elf and elf, print elf, this is by key, so right? Oh, there's also not that many elves. Interesting. So the sleepiest elf, well, I could probably, if I index into elf, this is more elf ID. Okay, that totally works. So this is how you loop over a dictionary by key value entry. Well, key, and then you can pull out the value by referencing the dictionary. And then finding the sleepiest elf. So this would be one elf. That's one elf. And so for this elf, really that's the elf. And then for this elf, I would like to compute. I would like to compute the amount of time it's been asleep. So how do I do that? Um, Elf would then be a shift. No, a list of shifts. Right, yeah, it's a list of shifts. So basically, for shift in shifts in elf, blah. And then we're going to want to, for elf ID in elves, well, we could keep track of sleep totals as a dictionary. And then basically, if elf ID in sleep totals dot keys, I think we can do that afterwards. But that was basically like inserting into an accumulator the, the the initial value, else incrementing the value. So sleep totals is a dictionary that's empty, and then for every elf ID in elves, let's grab the elf, and then for every elf, for every shift in the elf, for every shift in the elf, a shift will consist of one or more lines. So the second, if there's a second entry in any shift, that means we begin sleeping, and th there is necessarily a waking up event, right? I think there's always a waking up event. They always wake up before 1 o'clock. It's never the case where like 1 a.m. hit comes by and their shift sort of ends. They always wake up before the shift ends. So for shift in elf, if the length of the shift is greater than 1, then we're calculating stuff. We want to determine the sleep time and start accumulating that. So if length shift is greater than 1, then sleep begin is equal to shift the second item, and sleep end is equal to the third item, and we need to generalize that. So actually you probably want to loop if length and shift is blah, then loop for entry in, I could do I, for I in range. Basically, I want to start from 1 to the length of the shift. And then begin is equal to sort of shift I. I mean, I could chunk them too. I've used chunking previously in the past. No, that's not it. Basically, chunking is a utility function that groups a list by a certain amount. So I could group these in sets of 2, and maybe reason about it better. But maybe I should just do it the right way. Find the sleepiest elf. For elf ID in elves, elf is equal to elf ID for shift in elf. If the person fell asleep, if the elf fell asleep, for I in we could probably simplify this by just having one for loop. For shift in elf, for entry in shift, if and then we want to sort of for shift in elf, okay, for every shift, sleep sum is equal to 0. And then for entry in shift, if we have a sleep, if a sleep is in the string, then sleep sum is 0, sleep begin is equal to 0. When we fall asleep, we want to set sleep begin equal to minute. And I don't think it's ever the case that the guard falls asleep before midnight. So sleep again is equal to entry dot um take one of these and figure out the regex for it. So, sleep is equal to this. What? S equals that. Anyway, I don't know why that didn't work. S is equal to that. re.search for what happens if you just search for a digit on S. Group 4. No such group. 0. 1. No such group. Digit. How about digit plus? It sort of grabs an item and then quits. I need all of the matches. Zero more characters at the beginning of the string matches regular expression. Return corresponding blah. Return none of the string is not matched by. Note that blah. If you want to look at it, you search instead. Okay, search. Scan through string, looking for a first location for regular search path. Produces a match and return a corresponding match object. So if I was more specific and said colon, blah, that would take out the minute. And then in the interest of time, I'm just gonna drop the first item, so everything from the first to the end. Okay, so I think that gets you the minute. And I'm gonna hope that none of them fell asleep before midnight. Also, that'd be a pretty lousy elf anyway, so it's the sleepiest elf probably. Group 0. Yeah, I have to say it's a very coming from JavaScript mostly. It's an odd way to do regular expressions. And I'm bumping up against the line, the width here. So sleep begin is equal to that, inclusive, right? So sleep begin is equal to that, and then if instead wake, we see wake. If we see wake in the entry, we can go ahead and calculate sleep sum as, and this is for the shift. We do want to keep track of the sleep sum because there might be multiple asleep and awake cycles in this shift. So sleep sum plus equal, well actually, well yeah, begin sleep sum plus equal some sort of delta, and I guess I could calculate sleep end just for clarity here, because it is going to be this nasty sort of regex with a dropping pattern, which, if I haven't mentioned before, I'm not a fan of, but I'm also sort of running kind of long here. Sleep sum is going to equal to sleep end minus sleep begin, and then we're going to reset honestly you don't have to reset sleep begin, and it doesn't seem like it's ever the case that sleep begin will be null when we need to subtract, so that should work. I'm just not sure if sleep begin will persist outside of this scope. So maybe we can check it out. I don't know. I'm still rusty on Python closures, so that might be a closure issue. Sleep sum. Right, sleep sum for the shift. So once we finish the shift, we've determined how much they've slept for shift and elf. Sleep sum. Then we're going to want to enter into sleep totals. Basically what I had outlined here. So if elf ID and sleep totals are keys, then I want to sort of increment sleep totals with the elf ID entry and not append but increment by sleep sum, and I want to do this here, I think, for shift and blah. If we've seen this off before, increment by what we've determined is the amount of sleep. Otherwise, we want to sort of define this entry. Sleep totals, alpha ID is going to equal the sleep sum. And then, what is it? pp.pprint sleep totals. So the sanity check. If a sleep blah entrance entry, if in sleep begin so that's skipping the first item. Unsupported operand type for negative stir. Well, sleep sum, sleep begin. I mean, this should be an integer, so. Okay. Those seem to be we have a very good elf here, 1171. And another very good elf, 2297. And so I kind of want just like the minimum of this. So I think I can do sleep totals dot values. I want to grab the min of this. Well, max, right? The sleepiest, right? The max of that, and then sort of, how do you get Python get key dict key by value? And I think it's like not a good, it's not designed to do it, but that's just how I tend to think. I wonder if there's a simpler way to do it. I mean, I could just do it visually. It's not that bad. 330, 3 type 3, 3, 3, 4, 5. Okay, 11993 seems to be the sleepiest. But I don't trust my eyes on that. How about that's like essentially like a calculator. 513, which is 1193. That I can trust myself visually to figure out. So basically we found out that ELF 111993 is sleepiest. And now determine sleepiest minute for this ELF. I want to go ahead and so sleepiest is going to be a shift, and it's going to be basically group shifts by ELF. You can grab ELF's entry 1993 and then pprint sleepiest, and let's see what that looks like. And I forgot if it's a string. I think it might have a pound in it. I think it has a pound in it. Oops. Okay, so these are the entries for, these are the shifts for the sleepiest ELF. So that's the sleepiest. And so determine sleepiest minute for shift in sleepiest. We want like the sleepiest minutes. So maybe minutes is also a dictionary. Maybe minutes is also a dictionary. Maybe minutes is also a dictionary. For shift in sleepiest, I need to sort of figure out every minute. Like, they begin the shift, they fall asleep, they wake up. So I need to sort of keep track of all the minutes. Yeah, pretty much we need to keep track of this entire hour as a dictionary. And probably keep track of a list of counts for shifts that where the ELF fell asleep at that minute. So we're going to have a dictionary of minutes that is 60 entries. For every shift, we're going to flip the bits in the minutes dictionary where the ELF fell asleep. And then at the end, just find the minute with the highest count. Yeah. I got this. Minutes, blah, for shift and sleepiest. For shift and sleepiest. Right. For entry in shift. I like lines better for line in shift. If you like that, ask me about that. For line in shift. If asleep in line, basically, if asleep in line, sleep again. Actually, I'm gonna go ahead and grab these. Sleep again is, we don't need to cast it for an integer, I think, here. Sleep end is that. We're basically going to have 60 entries in this minutes dictionary. Sleep again, sleep end, and then well, if we wake up, we flip those bits. So basically, this should probably be a list, honestly. Minutes 0 for I in range 60. And then I would hope that that is 60 wide. So what's m is equal to 0 for I in range 60. M is blah. Length of m is blah. Okay, so we got these bits. And we might make them dots just for consistency. This background is semi-transparent, so it looks better with the advent behind it. I think. Okay, so we got dots. We got these dots, and then so if we wake up, we want to sort of basically for I in range where we begin at sleep again and we end at sleep end, I think inclusive, so we're going to have to add a 1 there. So for that stuff, we want to go ahead and index into minutes and make that equal to, well, okay, that's kind of why I wanted it as a dictionary in the beginning, because I really want to count. Well, you could just make it a number and then it's a count. So it doesn't have to be a dictionary. It could be a list of integers I basically plus equal 1. Yeah. And so for shift in the sleepiest, we're going to determine the sleepiest minute. And then I think the answer is going to be, so for minutes, we can get the max entry in minutes. And then I would like to sort of get the index by that value. And I don't know if there's a way to sort of figure that out. So max minutes. So sleepiest min is equal to that. And so we can just do a linear search over it for minute in minutes. Well, we're going to have to do it by index. So for I in range length of minutes, if minutes I equals sleepiest minute. Well, sleepiest, not really the sleepiest minute, it's the sleepiest minute, count. And then if that works, then the sleepiest minute, I think I could do null here. Actually, I don't know if Python has nulls, but basically, so yeah, sleepiest minute is equal to I actually didn't even really need to do that. It's a direct thing. Print I. We could do sleepiest minute is I here. Just immediately. Well, actually, I might want that, so it might be 0. We could print it. We could also assign it is equal to I. And then the answer is the multiplication of these. So basically, int sleepiest, and we can drop the hash from it. It wasn't necessary, but whatever, times the sleepiest minute. Let's see if that works. Sleep end plus 1. So these need to be, yeah, okay, so they did have to be integers because I could go on to do integer stuff with them. Is that not it? For I in range, oh. So yeah, I don't know if now I don't know if I needed to cast those. Int argument must be a string of ice-like object or a number, not a list. Line 70. I mean, so sleepiest is, oh, it's a list. Anyway, I know that it's 1993, so I'm just going to multiply it like that. Whatever. How is the sleepiest minute 36? It's probably 37. Let's see if this is the answer. That's not the right answer. Your answer is too high. If you're stuck, there are some general tips on the About page, or you can ask for hints in the subreddit. Please wait 1 minute before trying again. You get 73741. These challenges are getting harder. Um, so I think I'm gonna punt on this because it's well over 1 hour and I haven't really even finished the first half. We're going up to like 1.5. Yeah, we're way past 1 hour. Video output too low. So it was healthy and then it's not so healthy. I don't know what I can do about that. But yeah, sorry if you really wanted to see the answer. Hopefully that was at least somewhat entertaining. I need to, and that's the goal with for me to do this. Like I've never really done competitive programming, honestly. So my goal with this is to just really lock in the Python facilities, the Python standard library in my mind, and sort of yeah. So being able to know the regular expression functions by heart is something that I want to get to, and what else? I did like that we were. So I've been trying to learn more SQL. I'm trying to get really good at SQL, and that sort of mentality, that sort of paradigm really permeates um, a lot of what I do and when I'm programming. So I like this sort of group by mentality. So we start with lines, and then we're grouping them into shifts, and then the shifts get grouped into elves, and then we can sort of ask questions about elves where we can sort of determine the sleepiest elf, and then once we have the sleepiest elf, we can sort of determine that elf's sleepiest minute. Um, I mean, I wonder what would happen if we did 1993 times 36. 71748. 71748. What is that all about? 'Cause I was gonna punt on that. So can we identify where the error was? There should have only been one sleepiest minute. That's why it's the sleepiest minute. So we know 1993 is sleepiest. Determine the sleepiest minute. Minutes for blah. So we know the sleepiest minute count is this. And then we should just be able to go in and determine. So the minutes we're keeping track of as a list. So what I really want is a sleepiest min count. This seems to have matched twice. So if minutes at some index is equal to sleepiest min count, maybe there are two sleepiest minutes. It should have only printed once. So well, anyway, very happy, very happy. I was really gonna just go on and punt on that, but I got a gold star, and definitely not going to tackle part two today, but maybe just read it. Strategy two. So okay, so there's two strategies for finding the best time to, I guess, try to steal something. Of all guards, which guard is most frequently asleep on the same minute? Which guard is most frequently asleep on the same minute? In the example above, guard 99 spent minute 45 asleep more than any other guard or minute. Of all guards, which guard is most frequently asleep on the same minute? Other guard or minute 3 times in total. In all other cases, any guard spent any minute asleep at most twice. What is the ID of the guard you chose multiply it by the minute you chose. In the above example, the answer would be 99 times 45. Not really following what that means. Which guard is most frequently asleep on the same minute? Above, it would be 99 by 45. 99 by 45. So guard 99 is most frequently asleep on this minute, but guard 10, oh, but guard 10 is the sleepiest. So the first strategy is find the sleepiest and then find their sleepiest minute. The second strategy is to find not the sleepiest guard, but the guard that is most frequently asleep at the same minute. So this guard overall is more vigilant, but they are they tend to fall asleep around the same time when they do go to sleep. So the variability here is much lower. At least in this example, the variability is much lower. Guard 99 tends to be asleep between minutes 36 and 54, whereas guard 10 was just really off that first time and then fell asleep a little bit around the middle. Not gonna tackle that this time around. I'm just gonna call it a day. So thank you very much. Have a great day. Enjoy your countdown to Christmas, and I'll see you some other time. Maybe hopefully tomorrow. Hopefully I'll see you tomorrow. Happy Merry Christmas.